I just wanted to make the clarity that, well, at the end I decided to cut the applications part in my presentation. I wasn't really able to make the full picture, to compose the full picture with the application. I didn't really feel satisfied with what I had, especially during the rehearsal for the pre-recording videos. So I will present mostly the historical approach in my talk. And well, second, you will see my presentation in a video. I have to apologize. For some reason, during the weekend, my connection is not really reliable. So that's the reason why I decided to make the presentation using the video. Well, that's all I have to say before the presentation. Thank you very much. As a starting point of this talk about the types and roles of thought experiments in Kant's philosophy, we can mention some definitions of what this type of experiments consist of. In his 1992 work on this topic, Roy Sorensen wrote that a thought experiment is an experiment that purports to achieve its goal without the benefit of execution. This definition emphasizes the dispensability of execution, but we could also define them as a hypothetical way of reasoning that aims to anticipate the consequences of an experimental situation, or as a display of the imagination that extracts the consequences of an initial assumption. We could also mention some popular or paradigmatic examples, such as Galileo's on falling bodies or Einstein's train and lighting. In this talk, then, I will present an exposition of 3 thought experiments coming from different works and stages of Kant's philosophical and scientific development, together with the arguments and textual evidence to support the claim that they can be so considered. The 3 cases are the Nebular Hypothesis, the second analogy, and the composition of motion in Phoronomy. Far from being an exhaustive exposition, this talk constitutes just a first assess of the types and roles of thought experiments in Kant's work. The first case I would like to draw attention to is a hypothesis stated in the first part of the Universal Natural History and Theory of Heavens. According to it, the nebula existing immediately after creation, shaped through the basic forces of attraction and repulsion, the celestial bodies with their characteristic shapes and orbital motions. In the very beginning of his Universal Natural History, Kant warns that his argument lies upon a supposition, namely, that the cause and the structure of our solar system can be mirrored to the whole universe. It is then a hypothesis about the systematic constitution of the universe according to Newtonian principles, and I would like to emphasize, in analogy with our solar system. Concerning this analogical character, Kant uses the term analogy to describe his reasoning, and in his introduction, for example, to the Universal Natural History 2012, Watkins described it as a transitivity of similarity through a double analogy. In Watkins' words, Kant draws an analogy between the structure of our solar system and that of the Milky Way, and then between the Milky Way and the fixed stars. The question I want to raise here is, what is the relation between analogical and hypothetical reasoning, and if we have already the terms analogy and hypothesis, what do we get from calling it a thought experiment? Following the Aristotelian account of analogy received by Kant through the medieval philosophy and his lectures on logic, it is possible to start tackling that question. Additionally, the structure can be more clearly represented with the help of Hesse's 1996 theory of analogy. This is how the analogy should look, I think, if we reconstructed it in such a way that it makes sense. Typically, we have a source domain and a target domain. We know a set of attributes on the source domain that are also observable in the target domain. The relations within each domain are called vertical, while the relations of similarity or difference between them are called horizontal. So from the horizontal relations, we infer a new relation of similarity, and in this way, we discover a new attribute in the target domain. It is worth noting that attributes in the target domain, of which we have not only discursive but intuitive certainty, comes from the experience evoked by Kant of looking at the sky in a clear night and noticing the bright band of stars describing what seems to be a circle. That is, watching the Milky Way with a naked eye. I didn't put this experience in the tabular representation for it wouldn't fit. That is, with this experience on the target domain, it wouldn't be enough to infer the desired relation. Strictly speaking, this would be the only attributes we are acquainted with on the side of the target domain, watching the Milky Way with the naked eye. Clearly not enough to infer the unknown similarity, but instead, the attributes in the target domain are assumptions. On one side, there are 6 planets and about 30 comets that had been observed so far. And on the other side, we assume many thousand more. And the same for the movement, the assumed movement of those apparently fixed stars. Additionally, Kant proposes an imaginary situation that would adjust the simple observation of the Milky Way to the structure of our solar system. So he wrote that if we think a plane drawn through the firmament in unlimited distances and assume that all the fixed stars and systems stand in a universal relationship to this plane, so that they are closer to it than to other regions, then an eye situated in this plane of reference will perceive this dense concentration of stars in the direction of such a drawn plane in the form of a zone illuminated by much more light. It's something similar to saying that you can see a circumference as a line or as an ellipse, depending on the perspective. So even the relation that was supposed, and this is an important point, so even the relation that was supposed to be inferred analogically is in fact an imagined situation. Moreover, the argument is inductive, but not strictly analogical. It infers according to the principle of universalization, but not according to the principle of specification. The former, according to Kant's lectures on logic, says that what belongs to many things of a genus belongs to the remaining ones too. What belongs to the bodies in our solar system belongs to the remaining systems and their compositions. On the other side, Kant wrote that analogy infers from particular to total similarity of two things according to the principle of specification. Things of one genus which we know to agree in much also agree in what remains with which we are familiar in some things of this genus, but which we do not perceive in others. For an analogy to infer total similarity, then it is necessary that the object under consideration falls under the same genus. The source domain must additionally agree, Kant says, in much of what we are familiar. Therefore, the analogy doesn't satisfy a requirement that I would like to call acquaintance, as it is shown by the textual evidence in the tabular representation of the analogy. The attributes on the target domain are assumptions. It is true that we are somehow familiar with them, but it is not the same type of acquaintance of the attributes that we can find in the source domain, namely our solar system. The only actual attributes of the target domain mentioned by Kant include simpler observations, like the bright band of stars visible on the dark sky and its circular shape. On the other side, as a hypothesis, the argument has to, and does, accomplish the requirement of unity. For Kant, and Kant says, the hypothesis requires unity. No more than one presupposition is needed in order to explain a multiplicity of consequences. As soon as we make many presuppositions, all the hypotheses lose some of their probability. In the case of unity, I infer that because many consequences fit with one ground, it is all the more probable that the true ground is reached and is the right one. It is true that the nebular hypothesis explains many consequences, like the shape of the so-called nebular stars, which turned out to be a system of stars, and more simple facts like the explanation of the shape of the Milky Way as we perceive it with the naked eye. But there are other consequences which are not accommodated by the hypothesis but derived from it, like the possible living conditions of possible inhabitants of other worlds. I don't claim then that the nebular hypothesis is wrongly called that way, for a thought experiment is indeed a piece of hypothetical reasoning, or that it doesn't resemble an analogy. It just seems to me that the persuasiveness and the impact it could have had in its time is better explained when we see it as a thought experiment. For that purpose, I will compare it with one of the cases of thought experimentation mentioned by Peter King in his work, Medieval Thought Experiments, the Meta-Methodology of Medieval Science. One of the several cases mentioned by King is the one of the late medieval philosopher Jean Buridan, who objected the theory known as anti-peristesis, defended by Aristotle, to explain projectile motion, according to which the air surrounding a moving body rushes in from behind in the space vacated by the projectile to impart a continuing force to the body and keep it in motion. King points out that Buridan makes his objection citing some experiences. A first one is that some things, such as a blacksmith's wheel or a child's top, spin without changing their place, and so it makes no sense to say that air rushes from behind the moving body. A second experience would be that that of a boat that suddenly stops. A boat that suddenly stops with us being on the boat and not feeling the air from our back. These experiences are not observational reports, and clearly they are not experiments in the modern sense. Thought experiments in medieval science then often recorded appeal to commonly held beliefs. They appeal to experience in the sense of what everybody knows, and could be procedures in accordance with imagination. These procedures could be, for example, possible situations with which we could bring about, though there is no evidence that anyone ever did, possible situations which we cannot bring about due to our lack of relevant power, but which could be brought about through the action of some other agent typically got, or situations which are not possible at all, examples constructed on the basis of per impossible. In stating the nebular hypothesis, the viewer perspective of the Milky Way from the inside of the imagined plane, namely a procedure in accordance with imagination in a medieval thought experimental fashion, is key for the probability of the hypothesis. This visualization accommodates the initial appeal to experience in the sense of what everybody knows, of watching the Milky Way with a naked eye on a clear night. These initial steps confer plausibility to the hypothesis that the fixed stars also behave in such a way that the orbits of the planets relate as closely as possible to a common plane, namely to the extended equatorial plane of their suns. As a result, we have a display of hypothetical reasoning with the form of an analogy that fits the medieval practices of thought experimentation. Turning from the pre-critical to the critical stage of Kant's philosophy, we come to the case of the second analogy. At this point, there is no need to build a case for showing how is it a thought experiment, or at least I'm not going to do it, for that work was already done by Martin Kalin in his 1972 article, Kant's Transcendental Arguments as Gedankenexperimente. Here we are concerned only with Kalin's distinction between what he calls a common and a Kantian thought experiment, a normal version of a thought experiment and a Kantian version of it. On the one side, there are common thought experiments that, in Kalin's words, serves the evaluation of hypotheses through the anticipation of some empirical consequences of its assumed truth and falsity. That's the standard definition with which I started this talk. On the other side, a Kantian type of thought experiment, according to Kalin, doesn't anticipate empirical circumstances but fundamental changes in the structure of experience. And the second, its role is the validation of a transcendental principle and not ordinary hypothesis. About the causal principle, Kalin suggests in his article that it can be described formally as a reductio ad absurdum and less formally as a thought experiment. As a reductio, it would have this shape. Assuming that the falsity of the causal principle, then some phenomenal event in the objective time would lack a cause, but it would also collapse the very distinction between objective and merely subjective time, leaving only a play of representations. Therefore, assuming the falsity of the principle implies both that the objective time exists in which at least one uncaused phenomenal event occurs, and that it does not exist. That is to say, that it remains undistinguishable from merely subjective time. On the basis of the generated contradiction, it must be concluded that the causal principle, rather than its negation, is true. What Kalin doesn't show is the actual thought experimental by which the causal principle is validated. It is true that, in principle, any thought experiment is reconstructible as a logical argument. But still, Kalin doesn't show what is the actual thought experiment. In their work on the origins of the philosophy of thought experiments, Vehige and Stewart suggests that the experiment Kalin is talking about is the example of the house and boat downstream mentioned by Kant in the second analogy. There is a contrast there between the apprehension of an appearance with a determinate order in its sequence, namely the perception of the position of a boat upstream, followed by its perception downstream, with the apprehension of the manifold of intuition when the series of perceptions have no determinate order, like perceiving a house. This illustrative thought experiment would show that the causal principle is necessarily present in the perceptions of something which happens. And in a more recent approach, Marco Busoni generalizes Kalin's reading in saying the following: the whole book, the whole first critique, can be seen as an experiment of pure reason, a philosophical thought experiment whose truth is guaranteed by the fact that human understanding loses itself in antinomies when it ventures beyond the limits of possible experience and attempts to deal with things in themselves. From this case, then, we can extract one more type and role for thought experiments in Kant's philosophy: a Kantian or transcendental type that aims to validate transcendental principles, playing a key role for the purpose of a critical philosophy. And the third and final case I would like to consider is the first part of a three-step proof for the proposition of the fifth explication in the part of the metaphysical foundations of natural science dedicated to Phoronomy. There, the proposition says that the composition of two motions of one and the same point can only be thought in such a way that one of them is represented in absolute space, and instead of the other, a motion of the relative space with the same speed occurring in the opposite direction is represented as the same as the latter. Proving it requires three independent proofs, one for each possible way of composing motion: motion in the same line in the same direction, motion in the same line and opposite direction, and a third case of motion in different lines comprising angles. The proof of the first case starts by granting that two motions in one and the same line and the direction in the same line and direction belong to one and the same point. That is, start by negating what is stated in the first case of a composition of motion in the same line and direction. The experiment consists of imagining two speeds A and B, and the speed represented by the segment below as contained in one speed of motion. According to Kant, the lines AB and the segment below designating the speeds are, properly speaking, the space they traverse in equal times, so their composition would have to express the sum of the two speeds that we can present in intuition as the compound segment above. Let's say AC, that is the composition or the prolonged segment AB. As pointed out by Michael Friedman in his reading of the metaphysical foundation of natural science, Kant's construction of nature, this construction and intuition do not represent two motions occurring in or at the same time. They rather represent two different spaces traversed by a given motion successively and not simultaneously. In composing two speeds, the composition of the spaces, another way to put it is in saying that in composing two speeds, the composition of the spaces and the composition of the times cannot be displayed in intuition without contradictions. This case and other cases in the metaphysical foundations, like the objection to the concept of rest as lack of motion, are close to what can be called the classic conception of thought experiments, of which Galileo's falling bodies experiment is the golden example. According this thought experiment goes as follows. Aristotle stated that heavier objects fall faster than light ones, so that if an object with a certain weight covers a distance in a certain time, another object with double the weight would cover twice the distance in the same time. Galileo confronted the law posed by Aristotle with the following reasoning. Suppose that Aristotle is right, and that, in addition, there are two objects, A and B, such that B is heavier than A. Grant also that the objects are tied to each other. It follows first that the system AB would fall faster than B on its own. That is, the system AB is heavier than B itself. However, it also follows from the initial assumption that, being A lighter than B, it would act as a parachute in such a way that the system AB would fall more slowly than B alone, with which a contradiction is reached. The proof has a clear thought experimental character, particularly within Orsted's philosophy of thought experiments, and who firstly introduced the term thought experiment when describing precisely the method used by Kant in the metaphysical foundations. In his historical approach on Orsted's notions of thought experiments and the Kantian foundations of the infinitesimal calculus, Kanitz summarizes the characteristics that Orsted attributes to the method of thought experimentation in Kant. Namely, one, technically and from the historical point of view, the first reading, the first properly speak account on thought experiment, the first Kantian account on thought experiments. The method, says Kanitz, has 5 characteristics. I would like to highlight the characteristics 2 and 5. In Kanitz's words, in thought experiments, the reason for the existence of a phenomenon and our certainty coincide, so that in representing, for example, the composition of motion a priori in intuition, it would be already proved, which could be generalized to all the constructions of the concepts in the Phoronomy, as the quote from the metaphysical foundation suggests. To summarize, we have from a historical approach some types of thought experiments in Kant's philosophy that include experiences of thought that agree with the scientific practices and standards of thought experimentation of late medieval scientists. Kantian experiments of pure reason in the sense mentioned by Kalin, and thought experiments in a Galilean fashion, or modern thought experiments properly called, and their roles conferring plausibility to a hypothesis, validating transcendental principles, grounding and developing physics, and serving for the purposes of critical philosophy. Thank you very much for your attention, and I will be pleased to listen to your questions and observations.